The next step of our derivative rules is the chain rule. And this is for when you have one function, g of x, inside of another function, f in this case. So what you're going to do is you take the derivative of the outermost function, f prime g of x, it says here, and then you multiply it by the derivative of the inside function. So it looks a little confusing written out like this. Another way to look at the chain rule, though, is that it is just that. It's the derivative of the outside times the derivative of the inside. So here's an example of a problem. I've got 2x minus 3 to the 4th power. I want to find the derivative of this, but I don't want to FOIL the whole thing out 4 times. So I'm going to use the chain rule. So we could say, try to write it out in a little color. h of x is something to the 4th. So there's your outside portion. What is to the 4th? Not just x, like we were doing with the power rules, but there's more to it. It's actually 2x minus 3 in here for this one. So when I find h prime of x, I'm going to first take the derivative of this outside portion. So I would treat it just like a power rule with an x, except that it's not x. Inside of here I've got 2x minus 3. And then I would just take this and multiply it by the derivative of 2x minus 3 here, the inside portion, to get 2. And then I put that all together to get that h prime of x is now 8 times 2x minus 3 cubed. So that's the idea. Let's look at another one. Very similar. Same idea here. I can rewrite it the same way. F of x is the outside portion cubed. And then on the inside, I've got x squared plus 10. So when I go to find f prime of x, it's going to be the outside portion, where that's x squared plus 10. It's just hanging out on the inside there. And then times the derivative of x squared minus 10 is 2x. Put all this together, and I've got 6x times x squared plus 10 squared. Be careful that you don't distribute here, because we've got a squared on top of our binomial. Because of this guy right here, I can't start moving this 6x in. It's done the way that it is. Just a common mistake that I see when I'm grading tests and stuff. But anyway, that's the idea. These can start to mix in with the other rules too. So right here, I have a product. Well, that means I'm going to have to use the product rule. And the product rule says that f prime of x is going to be x squared times the derivative of x minus 2 to the 4th plus x minus 2 to the 4th times the derivative of x squared. As I start taking these derivatives, I can see that right here I'm going to have a chain rule. So for this part, for this derivative, it's going to be 4 times x minus 2 cubed times 1 in this case. So I don't really need to write that because obviously times 1 isn't going to change anything, but technically, I do have to take into account the derivative of this inside part here. Not really a great example actually for teaching this. And then over here, of course, we've got the derivative of x squared is just 2x. And then we can kind of squish this stuff together, combine what we can. And we'll get that this is, let's see, that's going to be 4x squared times x minus 2 cubed plus 2x times x minus 2 to the 4th. Alright, so in this I can factor out 2x and x minus 2 cubed. So what I want to do to make this kind of easier to see, I'm going to put this green bracket around here, and then the stuff that's going to the outside I'll put out here separate. So I've got 2x times x minus 2 cubed on the outside, and so my same bracket, is going to end up in here. So what's left over from this section here, I just have 2x left over. So we'll give that a red underline. So this kind of went to that. And then from this one, I took out this 2x and all but one of those x minus 2's. So from here, I'm going to end up with plus x minus 2. So that piece came from there. Then I can combine this all one step further and get that this is 2x times x minus 2 cubed times 3x minus 2. And remember that as complicated as this gets, multiple rules, product rules, chain rules, power rules all happen at the same time. This is still slope of the tangent line. Never forget this part. Derivatives are slopes.